could be. No, I am over 60, so that doesn't work anymore. Okay, right, let's make a start. Okay, folks, if I could just ask you perhaps to mute, and if you turn off your videos, it'll just help the bandwidth, make sure that we don't have any problems. If you do need to raise a question, do just chip in, unmute and say something, or you can try using the conversational chat, but I may not see it, so that's the thing. The other thing to say for my NR colleagues is this is not a formal training course. This is just the ramblings of a deranged idiot about ETCS things. However, what I can say to the Network Rail colleagues is that we have run our pilot course on System Fundamentals 1, which is an e-learning course, and that went pretty well, and we're evaluating the results before the e-learning goes live. I believe that's still the correct statement, and Mel or Alan or Catherine, if they're on the call, might correct me on that.
That is correct.
Thank you.
It should be very soon. It will go live. So.
Okay. So one of the topics that people ask a lot about is system versions. How do they work? It's all bamboozling, and quite a lot of people have been on courses and they've seen a diagram looking something like that. At which point most people's eyes glaze over, and I'm glad all your videos are off because I can't see you now glazing over. But it sort of tells part of the story, but it doesn't really explain the story. So I'm going to try and explain the story in different words, using examples from ETCS, but also trying to relate it to things that are easier for us to understand. And the system versions issue is all actually around a language, and languages change with time. And Ken and I were just discussing the fact that the subsets are written in a form of English words which don't always match the dictionary definition or the colloquial definitions of those words. And certainly the structure isn't always clear. And if we take an example of a word nice, now, when I was at school, which is, of course, a long time ago, we weren't meant to use the word nice. It was a sort of word that you shouldn't write in essays. But if we look at that word in Latin, it implied a stupid, ignorant, or foolish person. As we moved into the 14th and 15th centuries, it became someone who was finely dressed, or perhaps was shy and reserved. They were regarded as nice. And by the 16th century, it was used for refined, polite society, things which were nice. However, in those undercurrents of local language and social media and things, nice now is moving back to more like the Latin of being undesirable in society. So language is always changing. And the same applies in ETCS. If we'd got the language right for the first variation of ETCS, we wouldn't need to change things. But as we've improved ETCS, added extra features, things like new messages have been introduced. So the language has changed. And within those messages, the meanings of some of the variables has changed. And also the values that variables can have has been changed. So this language, like the word nice, has been evolving as we go through. And there have also been some older messages or parts of messages which are no longer required and get deleted. I think everyone on the call will understand that ETCS is all about safe communication between an ETCS trackside and an ETCS onboard. And for that safe communication to take place, both parties need to be speaking the same language. If they're not speaking the same language, it can't be safe because someone will be making an assumption and that could be wrong. So that's fine if our trackside and our onboard are built to the same set of specifications. They will then share that common language. But what happens if the train is newer, perhaps, than the trackside? Well, the trackside is still going to use that common language that it was using before, but the onboard now has the capability to understand a newer language. And so what the onboard needs to do is to interpret the messages it receives from the trackside, and also make sure that when it sends messages back to the trackside, they're in a language that the trackside will understand. So if the onboard's newer than the trackside, the onboard primarily does the interpreting. And you can argue that you could do exactly the same the other way around. You could take a 158 off Cambrian running baseline 2, and you could put it on 0 to 12 out of Paddington, and you could configure the trackside to do the interpreting. So that's the theory, and system versions is all about helping the onboard and the trackside know which of them has to do the interpreting and how to do that interpretation. Unfortunately, as with many things in ETCS, it's not that easy, because interpreting something can restrict the message content. When I do the talks for our colleagues going to Brussels with our colleagues from around Europe, one of the things I make clear at the beginning is that English is a language where we have lots of words which can mean the same thing, and lots of words can mean many things. So in order to interpret something, you have to also know the context. And for ETCS, that's quite important, because the older ETCS language didn't support all of the messages that are in the current language. And so you have to make assumptions to fill in the gaps. But interpreting things can lead to misunderstandings, and those misunderstandings could become unsafe. So let's have just a look at an example of how having two different versions of the language at either end of the communication channel could lead to something that's unsafe. Well, baseline 3 introduced a packet 88, which is around a level crossing. And it basically is a means for the trackside to send a simple command to the onboard to saying stop on the approach to a level crossing. And once you have stopped, then you can proceed at a reduced speed. This is typically where the crossing is not protected. You could use it for a locally monitored level crossing if you wanted to. And I believe it is being used for Placer's level crossing on the 0 to 12 scheme. So in baseline 3, that packet exists. However, there is no equivalent in baseline 2. So if that information needed to be sent, there is no way that you can just interpret the packet 88 into something that a baseline 2 onboard could utilize. So we have a problem. One of the other things to remember with ETCS is that tracksides generally don't move around. Once you've built them, they stay where they are. And the ETCS operation is within well-defined boundaries. So the trackside normally has a fixed system version. The onboard has to do all the clever things. The world is its oyster. It can go anywhere that is got ETCS equipment, and it should be able to operate with any ETCS trackside. That would be our goal. So it's actually the onboard that's going to be doing most of this work in interpreting. So how do we get a common understanding? Well, as I just said, it is the onboard that moves around. And so up to baseline 3 maintenance release 1, the obligation was almost totally on the onboard to do the interpreting. The trackside just did what it did, and it was the onboard that had to listen to the trackside messages and then interpret them to apply to its own rules. Baseline 3 release 2 introduced some mechanisms where the trackside needs to do some of the interpretation as well. And that's becoming even more of an issue as we move to the next release and things like ATO are introduced, where the trackside may have to adjust some of its messages depending on the capabilities of each individual onboard. So we're going to need to achieve this common understanding. And if we just let them communicate, there's a good chance that they'll get it wrong. And some of you will remember this video. So you may remember that from Hitchhiker's Guide to the Galaxy. And if just as a little aside, if you weren't aware, all of those graphics were produced not on a computer, but actually with coloured gels and drawings and people moving the coloured gel around to reveal each of the letters. Anyway, going back to what we were talking about, the babel fish in that example is something that interprets what is heard. And we could say that exactly the same thing needs to happen in ETCS. So the onboard needs to have its own little babel fish to be able to understand what the trackside is saying and trying to tell it. The slight difference is that because messages flow in both directions, with ETCS, what you say also needs to be translated. And I suppose I could have found one of those apps where, you can talk in Japanese or talk to it and it will talk in Japanese for you, and vice versa. So the first part of having a conversation is the understanding what language we're going to speak. So if we imagine that we're in a foreign country, we might be able to guess what language someone speaks, or we could try some common words of greeting and see how they respond, or we could ask them in our broken schoolboy French or schoolboy German, sprechen Sie Anglais? Or no, that's not quite work. Right, anyway, you know what I mean. Now, ETCS needs to do exactly the same, and the first part of a communication session is to do that process of understanding. Chapter 3, subset 26 has this lovely little diagram where the onboard starts the communication session and the response of the trackside is with the system version. And if that is compatible with the onboard, then the session is established. So let's just have a look at what is that response from the trackside. Well, it is a message 32, and within it, it includes the version of the ETCS trackside system. And that's defined in the various subsets, and there are a variety of numbers that are allowed to appear in that field. And we're going to come back to those version numbers and what they mean a little bit later on. So when the onboard receives that response, its first question is, do I understand a language with that system version, and can I support it? And if I, as an onboard, can't work with that language, then it would not be safe to continue. So the answer is to terminate the session. However, normally the onboard is more recent than the trackside, or certainly no older, so it will be able to understand the trackside language. And its next question is to say, do I need to actually tell the trackside about my version? Now, this is a later introduction, but it is a part of the specifications that we're applying for future schemes, is for the onboard to advise the trackside which versions it can support. And so the reply from the onboard to the trackside includes that version list. If we are at baseline 3 release 2, which everyone would like to be for both the trackside and the onboard, of course, this is all very simple. But what happens when we start having different versions in the onboard and in the trackside? They're going to do things slightly differently. And this is where chapter 6 of subset 26 begins to come in and modifies the behavior of the onboard or the trackside. So if you looked at the specifications for Cambrian 230D specifications, or even at baseline 3 MR1 specifications, the response from the onboard to the trackside, message 159, includes 5 fields, and the last one is an optional packet. The optional packet is normally packet 3, which is a list of the telephone numbers for the onboard. But it doesn't have to be included. However, if we move on to baseline 3 release 2, and the onboard is talking to a baseline 3 release 2 trackside, it will respond with a packet 2 in that optional field. And it's no longer optional, it is now mandatory. And packet 2 is a list of the system versions that the onboard can support. So in baseline 3 release 2, that is what happens. However, there is a problem. If I'm a baseline 3 release 2 train operating on an earlier version of the trackside, for instance Cambrian, and I send a packet 2, the trackside will not understand the packet, and that will almost certainly generate an error. So my baseline 3 release 2 onboard, when it is talking to a 230D trackside, which it will know from the system version that was sent by the trackside, modifies that message 159 to replace the packet 2 with a packet 3. And this is described in chapter 6 of subset 26 for the baseline 3 release 2 specs. You can see why people are beginning to get confused, because it's quite a long sort of qualifiers on what happens. And just to make it a little bit more interesting, if you are a baseline 3 release 2 onboard talking to a baseline 3 maintenance release 1 trackside, well then you can have a choice. You can either send packet 2 or you can send packet 3. And this is another part of exactly the same chapter 6. Obviously, because the onboard knows about the version of the trackside, it is actually going to make the correct selection and would normally only send the packet 2 to a trackside that it knows will understand it. And it's normally about this point that most people reach for the packet of aspirins, because it's pretty tough and it's only going to get more challenging as we work through into the system versions. So I've mentioned these system versions. What are they? Well, they are a field in messages sent to and from the trackside and onboard, and they describe the language that the two parts of the system are capable of using. And the system version is stored as 7 bits of binary data. So 7 zeros up to 7 ones, which gives you quite a good number. And in the very early versions of ETCS, principally being developed by the suppliers working in conjunction with other parts of the industry, the versions sort of started at number 1 and counted up in binary. And different suppliers would generate versions at different levels, and it was just almost it was literally just counting up. Once it had been proven that ETCS was a really good idea, and therefore everyone wanted to adopt it and they wanted to make it interoperable, it was decided that we need to be a little bit more formal. And so a formal set of specifications were published, which became 230D. And that split the field, this system version field, into 2 parts. 3 binary characters forming the X and 4 forming the Y. which gives us an X value of 0 to 7 and a Y value of 0 to 15. And that's where our system versions come from. And they are often expressed as X.Y. So when baseline 230D was first published, it stated clearly that all messages used by that version would be identified with a system version of 1.0. X equals 1, Y equals 0, or if you want it in binary, it's 001 for the 1, 000. It was also confirmed that all earlier deployments of ETCS, earlier versions, started with 000. And so they could then put a requirement in that a compliant 230D system would ignore any messages identified as being X equals 0 as being predating the system, and therefore they could be ignored and no error would be generated. So that was all nice and easy. Cambrian, Trains and Trackside both use system version 1.0. They can talk the same language. We can have that safe communication. When baseline 3 was introduced, it supports messages with the system version of 1.0. It maintains backwards compatibility. An onboard of baseline 3 MR1 should work quite happily on a 230D trackside. Baseline 3 MR1 also introduced an option of being able to send some extra information to an onboard, but from a trackside that didn't understand that information. And this is where it gets really confusing, because we have a baseline 230D trackside, but we can send information marked as system version 1.1, which a baseline 2 train will ignore, but a baseline 3 train will utilize. And as we go through, I'll try and explain that a little bit more. All the new functions, and in fact, all the functionality that's baseline 3 would be marked with system version 2.0 and would be available to a baseline 3 train operating on a baseline 3 trackside. With release 2, we introduced system version 2.1, and anything that was new in release 2 but wasn't included in MR1 is flagged with that system version of 2.1. So baseline 3 release 2 trackside and onboard actually supports 4 versions: 1.0, 1.1, 2.0, 2.1. And the next debate is whether the next release of the ETCS specifications will be 2.2 or whether they will be 3.0. It's all around compatibility. It also doesn't help, as you've probably noticed, that baseline 2 is system version 1.0 and baseline 3 is system version 2. It would just be so much easier if the same numbers applied. The other thing is that this is all a theory. It's a theory that you can have either the trackside or the onboard at any of these versions and that they can work together. It doesn't always work like that. So let's just go through a little bit of painful detail, because it is quite important, particularly for those of you introducing new trains onto an existing trackside, or for those of you understanding the impact of installing a trackside to more modern versions and the impact it could have on other trains that might operate. So baseline 230D onboard will read and process any messages which are declared as being version 1.0. That's its native language. It will read and ignore any packets within messages which are declared as 1.1. So if a Belize group message is declared as version 1.1, and there's a packet in there that the onboard doesn't recognize, it will just throw it away. It won't generate an error, won't have a get its knickers in a twist or anything. It'll just ignore it. However, if it gets a message which is declared as being version 2 point anything, 2.y, it will generate a trip. It's receiving some information. It recognizes it doesn't understand the language. It therefore can't be sure that the information being sent is not safety critical. So it takes a safety critical reaction or a safe reaction and trips. If we have a train which is baseline 3, maintenance release 1, and this would apply to 0 to 12 trains or the Thameslink trains, about there anyway, then any message which is received, which is declared as version 1.0, will be read, processed, and interpreted. That's backwards compatibility. Similarly, anything that's declared as 1.1 will be read and processed. And because baseline 3 introduces 2.0, it will also read and process messages declared as 2.0. But similar to the baseline 2 train, it will read but ignore any unknown packets in messages declared as 2.1. So again, it can work with a slightly newer version of the trackside, and it will just ignore things that don't matter.
And presumably, although a system version 3 doesn't exist, if you did send a message to a baseline 3 release 1 train with a system version of 3 dot anything, it would trip.
Yes, exactly the same process. And that's actually the debates that are going on now about the next release, because if we declare it as 2.2, we're saying that the majority of the language is compatible and the functions are compatible, and it's okay for a B3 MR1 train to operate on a release 3 trackside. But if we get to a point where the language is no longer compatible, or there are functionality which it is critical, then that forces us to have the next system version will be 3.0. And obviously, I don't really need to run through it, but a baseline 3 release 2 onboard will read, interpret, and process all of the messages, whether they be version 1.0 or 2.1. And just note that I am saying it is the onboard that's doing this because that is how the specs are written, that it is the onboard that does the hard work, and the trackside is pretty basic and simple. So for Thameslink, the core area of Thameslink utilizes an RBC, produced a good, well-trusted design, but actually is working to version 2.30D of the specifications in terms of its language. However, the trains, the 700 class trains, are operating on a baseline 3 version, and they can support up to system version 2.0. So the RBC, because it is a 230D specification, declares that its messages are version 1.0, and it'll be 1.0. It will report when a train contacts it. However, some of the Belize messages have version 1.1 in their header, so that we can use extra packets in those Belize groups, which provide extra information which supports the operation of baseline 3 trains. There are features in baseline 3, particularly around the brake model, where extra information enables better operation. So does it work the other way around? Well, in theory, yes. You can have a trackside which is working with onboards from an earlier system version. But in order to achieve that, all of the Belize groups need to be configured to be that earlier system version. So anything that's more useful in the language, anything that's from that later version, you can't implement through the Belize groups. And similarly, the RBC would also need to work as if it was an earlier version. Any modern functionality would have to be ignored, and all the messages would have to be configured to that earlier version. And in fact, it's just not practical. It's a good theory, but it doesn't work. Everyone would get confused, and our language and communication would break down. And it's that sort of confusion that can happen between a trackside and onboard if we don't make sure we both speak the same language. And the way this is managed within ETCS specifications is subset 26, chapter 6. Those of you who've been to some of my other talks will know that chapters 7 and 8 define the messages and the packets and the variables. Chapter 6 defines the changes to the language to enable different versions of ETCS to communicate safely. Now, like a lot of the subsets, in fact, probably even more than the other chapters in the subsets, chapter 6 requires a certain mindset. What it's trying to do is telling the onboard how to interpret messages that it receives from tracksides with earlier system versions. And it's also describing how the onboard should reconfigure the messages it sends to those tracksides, which are earlier, so that they don't get confused. And just to add to that, in some cases, it also says that the trackside should respond differently depending on the version of the onboard it is talking to. So subset 26 contains chapters 3, 4, 5, 7 and 8, which define the operation of the ETCS for that particular system version, that release of the system. And what chapter 6 does is contain a series of amendments to those chapters. And it is really quite hard to actually read those amendments and understand what they mean, because it's almost sort of like reverse Polish logic for those of you who remember the early Sinclair calculators. It takes a different way of thinking. So just to give an simple example, all system versions have the capability for the transmission of national values from the trackside to the onboard. And the purpose of those is to configure the onboard so that it's aligned with the engineering rules being applied to the trackside. It's things like the maximum speed in staff responsible, for instance. And in baseline 3, so version 2.y, packet 3, which contains the national values, has a long list, and you can see it fills up 2 columns of the screen. And all of these things are things which will affect the behavior of a baseline 3 onboard. However, some of them are only applicable to a baseline 3 onboard. So the ones I've highlighted don't affect a baseline 2 onboard. And in fact, the baseline 2 version of packet 3 is much simpler. So what chapter 6 says is that if our baseline 3 onboard knows that it is talking to a baseline 2 or system version 1.0 trackside, it will need to expect a packet 3 which has this shorter list of variables within it. And it will use those in the same way as if it had received them from a version 2 baseline 3 trackside. Now you'll remember that I'd marked up a whole series of variables with highlighter which aren't included in this version of packet 3. So what do we do about those missing values? Well, in the absence of other information, the onboard can apply defaults or make assumptions about what those variables should be. Those defaults could be defined in the onboard, or they could be defined in the specifications. But what if those values are actually useful to us for the operation of our baseline 3 train? Well, that's where we have the option of sending an extra packet. Packet 203 can be sent in a message which has got a header to say that it's version 1.1. If it's sent with a version 1.1, if it's a baseline 2 train, it will ignore the packet because it doesn't understand it, but it won't generate an error. If it's a baseline 3 train, it will read the packet and it will understand that it needs to add those extra values to the list of values it got in the packet 3 from the baseline 2 version 1.0 trackside. So chapter 6 has amended what the onboard will expect from the trackside, and it has also said how to cope with something which will be sent. And packet 203 can only be sent by a baseline 2 trackside. So although it is in the baseline 3 specs, it is actually in a baseline 2 trackside that sends it. And that caused a lot of confusion with Thameslink, where some people thought that the trackside was baseline 2, and other people argued that because it was sending packet 203, which was only specified in the baseline 3 specs, the trackside must be baseline 3. So how is our train, our baseline 2 train, going to react if it receives packet 203? So this would be perhaps if we ran one of the 97s through Thameslink Core, or when we first ran the 313 when it had baseline 2 software on it. Well, if it receives an unrecognized packet, normally that will generate an error, and that error will lead to a break intervention. But if we actually look in the baseline 2 subsets, and this also applies to baseline 3 to pick up Peter's comment from earlier, is that the version is identified by a version x.y. The first number, the x, distinguishes whether the version is compatible. If the first number is lower than the one you are operating to, then it is compatible. If it's higher, then it's incompatible. Whereas the y part of the version indicates compatibility within the version. It then goes on to say that when a message is received from a Belize group, if the version is not compatible, the train will be tripped, which is reasonable. But if it is compatible, then information which is not known is just ignored. So packet 203 will be ignored by a baseline 2 train. Now, I guess at this point you probably do want that packet of aspirin because it does get quite complicated. How's that achieved? Well, in the Belize telegram, in the header, we can include the version of the ETCS system to which the Belize group is working, and we can put in 1.1 instead of 1.0, and that will tell the onboard to ignore any of those packets. So chapter 6 is changing the structure of our language. But in order to maintain backward compatibility, a little bit like your computer system being able to run older versions of Word or whatever, you need to make sure that everything is clearly understood. And sometimes the meaning of the words, the variables, also changes. So when an onboard reads any message, one of the things it does is to check whether each of the variables has a valid value attached to it. And if it doesn't recognize the value, for instance, because it is defined as a spare value, then it will generate an error. So to take an example, one of the variables in the national value package is a NV max reduced adhesion 1. Bit of a mouthful. And in baseline 3, maintenance release 1, which was the first time this was introduced as a variable, it has a range from 0 to 3.15 meters per second squared, because it's a 6-bit binary number and the resolution is in 0.05 meter per second squared units. And you can see there are no spare values. All of the values are used, and that will how it work. If we move on to baseline 3 release 2, in baseline 3 release 2, the top 3 values expressed as decimal have now got special reserved values. And those reserved values were introduced to control the display on the DMI for a baseline 3 release 2 train. So now we have an interesting question. If I am a baseline 3 release 2 train operating on a baseline 3 maintenance release 1 trackside, and that trackside sends a very high value of NV max reduced adhesion 1, it could actually cause the DMI to display things. However, going the other way around, if I have a baseline 3 maintenance release 1 train, if it receives the values 61, 62, 63, it will just treat them as valid values. It will not generate an error. Which naturally brings me on now to a key point about system versions and the specifications, and one that probably my colleagues from the railway undertakings will be interested in. The onboard core behavior doesn't change when it gets a different system version from the trackside. The only thing that changes is the language at the interface and how it is interpreted or modified to communicate with that different version of trackside. So if you've got a baseline 3 release 2 on board, its DMI will stay the same even if it transitions between a baseline 2 trackside, a baseline 3 MO1 trackside, or a baseline 3 release 2 trackside. It doesn't change back to reflect the trackside. So it stays consistent. And similarly, a baseline 3 maintenance release 1 DMI and all the core functionality stays the same. It is just the inputs that it receives from the trackside which are amended and translated. And that then leads us to even more complexity where we change the philosophy. So in baseline 2, speed profiles were sent in 3 basic categories. Category 0, active tilting standard static speed profile, passive tilting static speed profile, and a crosswind sensitivity speed profile. So we only had some very restricted options of what we could send. But with baseline 3, people wanted to do a lot more. And so the same variable NC_diff now has different meanings. And there is another variable NC_CDdiff, which has a whole range of settings, and we can have multiple speed profiles. So if I'm a baseline 3 train, I'm expecting to receive in the speed profile speeds related, categorized by NC_diff, and also potentially speeds categorized by NC_CDdiff. And my brake model, my speed model, all those models are built on receiving both of these fields and knowing what they are and being able to compare them to the characteristics of the train. But if I sent my baseline 3 train to Cambrian, it's going to only receive the information from the trackside, which is NC_diff. But in order to do all the other calculations, it actually needs to work out what the equivalent other values are. So we have a translation table. You can see down the left-hand side the values that could come from an x=1 trackside and how they're translated in the onboard. So x equals 1 of 0 translates to an active tilt, and that is basically having a potential of a 275 millimeter cant deficiency, which means that NC CD diff is set to 9. Passive tilt, it's a potential of 80 millimeter cant deficiency, so it's set to 0, and a crosswind sensitivity is set to 1, and that's potential of 100. So those are the three that a classic baseline 2 trackside could send, but you can see in chapter 6 of the baseline 3 specs, it actually says that the trackside could send up to a code of 13. And those codes up to 13 will be translated by a baseline 3 train. But the question then is, what would a baseline 2 onboard do if it got those other values? Well, if we look in the specifications, there is a criteria for accepting messages, and one of them in part A there is that variables shall not have invalid variable values. And if you look in the baseline 2 specs, then NCDiff 3 to 13 are defined as spare. That presumably means they're invalid, and if they're invalid, and it says so in fact in the clause at the bottom, then you should generate an error. So we have, at this point, I think that probably describes my head, if not yours. We've got quite a confusion of trying to work out what is interpreting what, how it interprets it, and then how it uses the information. So let's just remind ourselves a couple of key points. From a driver's point of view, driver is quite important. The driver sees and experiences whatever the release of ETCS which is installed on board will deliver. He or she will get the information in the format that it will be presented. It won't change just because you move to a different type of trackside. However, if they drive different onboards with different releases of the onboard system on the same route, each time they travel on that route, they may get a different experience. So if you're driving a baseline 3 release 2 train, the colors on the DMI, when they change, the format of the some elements of the planning area will be different to if you're driving an MR1 train on that same route. The core supervision stays the same, but some of the information displayed will change. The aim is that the experience of the braking system and the supervision shouldn't change because the trackside changes. However, there will be some presentational changes. And that's probably something we will need to think about as we train drivers going forward. The trackside declares its system version, and it can do that in two ways: at the establishment of the session or in the header of each of the Belize messages. And the onboard has the task of working out how to translate the information. It needs to work out whether it is compatible in the first instance. It will always be compatible with the same or a lower value of X. It will then interpret the information, but we also have this facility that it will ignore packets in Belize messages where the Y value is higher than the onboard's Y value. So it won't generate an error. And it is chapter 6 of subset 26 that tells the onboard, primarily the onboard, how to interpret those messages it receives and also how to configure the messages it's going to send out. It is the onboard that is not just the babel fish for the incoming messages, but also a babel fish to translate the information going out.